Okay, so where's my open math here? So this next one, they're giving us a parabola, an upside down parabola. They want us to do all the left-hand LRAM, RAM, and MRAM on it on 0 to 3 with 6 subintervals. Unfortunately, they didn't have to do 6, but that's okay. So we need to do the answer. Now, you can get the answers by using that output I showed you if you watch my other video. And remember, that's in the what to do. You click on that RSum link, okay? It's good to know how to do this though. So, I mean, like I said, I'm going to ask you to do this on the next exam. Won't be a tedious one. It'll just be show me the setup and everything. Okay, so because you got to know how to do that approximation. It's one of the essential objectives for the course. CCV set that. So let's see. So we could graph. Where's my open math? We could graph that with graphing calculator with Desmos, right? I started setting it up by hand. Let's see. Let me come back to my. Oops, no, there's my graphing calculator. I'm going to show you that in a second here. Is that it? No, that's the next one. Here we go. So the analysis that I did, I found the vertex. I chose to do the derivative, set it equal to 0, found the x value where the turning point is with the maximum in this case because it opens down, it's concave down. And then I evaluated that in the original function, and I got that the y coordinate is 24.5-ish. So, and then I found the zeros. I factored out a 2x, and I said, so it's going to be cross the x-axis at 0 and cross the x-axis at 7. And I sketched that in. And then I saw, okay, so they want us to find the area from 0 to 3. So actually, I drew a way too big a graph. No, not here. Sorry. Let's exit this. Guys. And so I shaded in what I want to find. Then I blew it up to another thing. And then I sketched in the LRAM rectangles. I mean, if we're going left end, the left end points is going to be 0, and we know I could just write in 0 there for how high it is. But the rest of them, I wasn't too sure. I mean, I didn't really want to plug in 1/2. It wouldn't have been impossibly hard. I certainly could have done that. But I wanted to also not make this tedious for you. Now, if you've got a graphing calculator, I don't know how much you've used it. Let me show you how to do this. This works all the way back to TI-82s if you have one. If you have something other than Texas Instrument, I know it does it. You can use a spreadsheet. There's a lot of things. There's that emulator you can get for your phone. What is it? TI something other. So what you can do with your graphing calculator, you can throw that equation in. And what do I got here? Clear. Let me clear out what's in here. So then I'm going to go up and plug in, substitute in. What am I substituting in? What's the function? 14x minus 2x squared. So 14x minus 2x squared, okay? And then I could graph it. I could do that. Well, maybe I should graph it just to see how I did. I'm going to do a zoom 4. I think that'll work. But that does decimal values. Oh, no, it doesn't go quite high enough, does it? That's because it's 20. So what we can do is tweak it. Actually, I might even see the other bound. That's because let me do zoom 10, and then I'm going to tweak it still. See, zoom. I don't remember how to do this. Zoom. I don't want to zoom decimal. I don't want to zoom square. What's zoom standard? Oh, zoom 6, right? -10 to positive. See how it's not quite going high enough? So we're going to go to window, and I'm going to change my maximum. What was it? 24.5. So Y max should be up to, let's go 30. And graph. Let's hit enter and then graph. That'll let me see more or less what I got. Okay, and I can tweak the window. So yeah, I'm in the ballpark, right? Now, I want to, but the whole reason I'm doing this is to evaluate, get those values for how high it is at each of those rectangles. So this is what you can do. The great feature of these calculators. If you do second table set, see over the window how there's this table set. I'm want to start at 0, and then I want to have it go every, what was it? Every half, was it? So I'm going to take my delta table 0.5. That's how the increments. It's going to, so it's going to evaluate the function at 0, then it'll go have evaluate it at 0.5, it'll evaluate it at 1, it'll evaluate it at 1.5, so on and so forth, and leave these both auto, because that way it'll automatically do that. And then just do second table, and this is how high the values are at the functions, and so we'll want to copy down the 0, the 6.5, the 12, the 16.5, blah, 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 okay? Okay, so I took those numbers off my calculator. Just a minute here, I got a disaster going on. Took those numbers off my calculator and I wrote them in my table. I also decided to save myself a step. I just scrolled down a little bit more and grabbed the y value for when x equals 3. We don't use it for the left RAM, but we'll use it for the right RAM. And then each of these intervals, each of these rectangles is 1/2 wide. So I multiplied and add them up. Truthfully, what I did is I thought about the distributive property. Since all of these are being multiplied by 1/2, I just found the sum and then times that by 1/2 or divided by 2. So that's my LRAM. How about the RRAM, the right RAM? So I sketched this in, I same intervals. I just did the right corner of the rectangle, and these are just the same values, except what am I not using? See how for the RRAM, I'm using the value for 0.5. I don't know that I sketched that in right. 1, 2, 3, 4, 5, 6. I didn't sketch that in right. I should have been here. Let me fix that. It should have been this one. Should have been right there. Yep, sorry about that. So I'm going to use the 0.5. I'm not going to use the 0. So I didn't include that. So I went with 1/2 times 6.5 and times the 1/2 times the 12 and blah, blah, blah. And then the 1/2 times the 24 that happened when x equals 3, which I didn't worry about the first one. That's how high that last rectangle is. And then I multiplied it and added those together, and that's what I got, a much bigger estimate. Okay, so that's the RRAM. Overestimation, underestimation, because these are concave down, because this curve is concave down. LRAM will give me an underestimation, RRAM gives me an overestimation. It's over it. So then they want me to do an MRAM. So what I did here is I started this, I didn't quite finish it. I sketched in the curve again, and then I found the halfway points, the midpoints of each of these intervals. See the 1/2 and the 0.75 and the 1.5. So now I got to find new values. I got to find, f of 1/4 and f of 3/4 and so on and so forth. So on my calculator, where's my calculator? Oh, come on. Here. No. Here we go. What you can do is you can go to table set, second table set, and I'm going to start it at, what was it? It was 0.25, and then have it increment up 1/2 each time. So I'm going to do second table, and you see what it did. So those are the numbers I need, and I need to go up to what, 2.75. So I need to write down these numbers, find the sum of them, times them by 1/2, and that will be my MRAM approximation. Okay, I don't know if you need to see me do all that because it's the same setup. I would just write down 1/2 times that, 1/2 times that, 1/2 times that, 1/2 times that, 1/2 times that. Okay, and then that would be my MRAM approximation. And what you should see is that they're the average. It's the average of the two, and they don't ask you this in this math exercise, but that's what happens. It's the average of the LRAM and RRAM. And of course, you can always check your work with that this applet. Okay, just change the function. All right, well here, why don't we change it? It was 14x minus 2x squared. And 2x, come on, Dan, 2x squared, and we want 6 subintervals, and we're going from 0 until 3, and there. Okay, MRAM, LRAM, RRAM. See, I'm glad they agreeing with what I got by hand. Okay, so that's how you do it, and that's how you check. And shortly, we're going to leave this behind, other than the hole where we're going for the rest. The rest of this is length times width. That's all we're doing is rectangles, unless you're doing trapezoids, and trapezoids are another form of estimation, which don't lend itself. It's just a better form of estimation. Okay, so I hope this helps you out. Give me a yell if you need help there.